Sorry about that, girls. You're going to have 2 videos for this day. Lesson 123, 124 on one, and then lesson 125. Mr. Courtwright stopped me. He thought I was messing up, but I was doing right, which is kind of a shocker. So lesson 125. Okay, lesson 125 is calculating areas of rectangles. I am going to read through this one. This is probably a little bit longer than the other 2 because we've done the others 2 a little bit, so I'm pretty confident that you girls know what to do, and I went pretty quick, but I want us to look at, we're going to read through this real quick. It says, we measure the area enclosed by a polygon by counting the number of squares needed to cover an area. We agree to use squares of specific sizes to measure an area. A square that has sides 1 centimeter long is called a square centimeter. This is the actual size of a square centimeter. Now, it shows you a picture there. All 4 sides are exactly the same, so that's called a square centimeter. Look over at the top of the next page. It says a square has sides 1 inch long. It's called a square inch. This is the actual size of a square inch, and you can see the picture there. A square with sides 1 meter long is a square meter. A square with sides 1 foot long is called a square foot. Now, if you'll notice, in this lesson, as I'm reading to you, it has those in bold letters. That means it's important. So when you go back and you get confused later on in the book, and you have a problem that tells you go look at lesson 125, pay attention to what it's showing you here when you go back and look at it. Okay, so I'm going to read that again. A square, a square with sides 1 meter long is a square meter. A square with sides 1 foot long is called a square foot. We use the abbreviation SQ to stand for the word square. These squares are bigger than this book and are used to measure large areas, such as the area of the floor in the room, like this room where I'm at right now. Even larger areas may be measured with the square kilometers or square miles. We have noted that it is necessary to draw figures in a reduced size so that they will fit on the page. In the following example, we have drawn a figure smaller than 2 inches by 3 inches. We do this so that the figure will fit on the square, on the space that we have. So the example they give is how many square inches are needed to cover the area of this rectangle. Be sure you label your squares. So if you look at that, what you see is 2 inches by 3 inches. I'm going to erase this before we get to go into here. The solution, the next part says solution. The length of the rectangle is 3 inches, so we can fit 3 square inch stickers along the length. The width is 2 inches, so we can fit 2 square inch stickers along the width. 2 rows of three mean that we can cover all the area with what? 6 square inches. And the pictures are showing you exactly what we're doing. Now, if you turn the page, we're already to the practice problem. I want you to look at practice problem A. It says, what is the area of each rectangle? Show the squares and count them. Now, Mr. Courtwright will probably interrupt right here because it's basically a multiplication problem, right, Mr. C? You're not listening? Okay, that's great. He's not listening. So that first one, it says that it is 3 centimeters by what? 4 centimeters. So we could draw the picture and all of that, and we would, but what can we do? It is a multiplication problem. 3 times 4 is what? 12. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's easier if you know your multiplication tables, you can just rattle that right off. So A, the answer is 12 what? Now, normally we would say 12 square centimeters. But Mr. C says you guys are so smart that you're ready to take the next level. Instead of writing it like that, like the book is wanting you to, you're going to write it like this. You're going to write it as 12 centimeters squared. Remember, we talked about exponents. So you can write it just like that. So all of your answers on these problems, I want you to write them like that. 12 centimeters squared. Okay? Now, let's look at the next one. B, what do you have? This is a trick question. All it has is 3 feet on one side. So what does that tell you? That means all sides are exactly the same. So all you need to do on that one, I'm going to draw you a little picture. If it says 3 feet, that means all of them are 3 feet. So all you need to do is, it's the same. It's still a multiplication problem. 3 times 3 is what? Right, it's 9. So you have 9 what? Feet, what? Squared. Good job, girls. I want you to do C and D on your own, and your assignment is to go ahead and do the evens like always. Now, I'll have another video for you tomorrow, and then on Friday you'll be taking a test. I sent home, I think, 3 tests with you guys, so you'll just do the next test that comes along. I don't remember what number it was. It's not a big deal. You girls are pretty smart. You'll figure it out. So you won't do that until Friday. The assignments are there for you. So good luck. Call me if you have any questions, and we can FaceTime or even Zoom maybe. It's no big deal. Mr. Brother David's got us training us to do this, okay? So you girls, I'm really proud of you. You're doing good. I've been correcting your papers. On Friday when you guys come and pick up some more, more assignments and whatnot, and to drop off your work, I will give you some corrections that I have for you, okay? Till later.